So this is a video clip presentation about the 6 important concepts that we often use when we are learning trigonometry. In trigonometry, there are two major branches. The first one is the plane trigonometry, while the second one is the spherical trigonometry. When we say plane trigonometry, we study plane figures, which is the triangle. We concentrate on the triangle. While in spherical trigonometry, we deal with triangles in a spherical manner, or in a sphere, okay, or in a polar system. So our target is for us to define these 6 important concepts that we often use when we are learning trigonometry. And these are the sine, cosine, we have tangent, secant, cosecant, and the cotangent. So these are the 6 important concepts or terminologies that we need to know when we are learning trigonometry. So let's try to define them one by one. However, before we define them, we need to consider our right triangle, because this right triangle is our basis for us to define these 6. So, of course, in a right triangle, we know there exists one right angle, and we only have one right angle in every triangle. That is a right triangle. And the remaining angles of that right triangle are both acute angles, of which one of these is the location of our reference angle. Now, the main important role of this reference angle is for us to identify the opposite side of that right triangle and its adjacent side. Of course, we know the side opposite of our right angle is the hypotenuse. It is actually the longest side among these 3 sides of our right triangle. Okay, now these sides that I am talking about right now are very important, have very important role in defining the 6 trigonometric concepts that I have already presented to you. So that will be our guide, that will be our basis to define those 6. Okay, so if, say for example, we want to define the concept sine. When we say sine, we often symbolize it, or in books, we often symbolize it as sin, or the sin, and it can be defined as the opposite over the hypotenuse, or in simpler way, it is the ratio of the opposite over the hypotenuse. So we are trying to divide opposite and the hypotenuse in that case. That is the definition of the sine function with respect to the reference angle. To the reference angle. In some books, they use reference angles as Greek letters, okay, and we often use the alpha or theta as symbols for reference angles. So say for example, with respect to reference angle theta, we can define sine as sine theta is equal to the ratio of the opposite side of the right triangle over the hypotenuse of the right triangle. For the cosine terminology, we can also define it with respect to our reference angle theta. So for us to be able to define it, it is by simply locating the opposite side of the right triangle and its hypotenuse. So again, we will try to get the ratio of this adjacent side and the hypotenuse. So when we say cosine theta, it is now equal, or it can now be defined as adjacent over the hypotenuse. Now, for the tangent function, we will concentrate to the 2 legs of the reference angle theta, which is the ratio of the opposite side of that given right triangle and the adjacent side of that given right triangle. So the remaining 3 terminologies that I have given to you are just the opposite or inverses of these first 3 terminologies that I have presented to you. For the second function, or for the second terminology, it is the inverse or the reciprocal of the cosine function, okay, or the cosine terminology. While the cosecant, it is the reciprocal of the sine. For the cotangent, it is the reciprocal of the tangent. So what we will do here for us to define the last three, the secant, cosecant, and the cotangent, is to get the inverse or the reciprocal of the definitions of the first three. Okay? So if in the sine function, or with respect to theta, we define sine as sine theta over opposite over hypotenuse, and I've said a while back that the inverse of this sine is the cosecant. So therefore, for us to be able to define the cosecant terminology with respect to our reference angle theta, it can be defined as hypotenuse over the opposite side of the right triangle. So that's it. So that will be our way to define cosecant function. In defining for the second function, or the second terminology, it can be defined with respect still to our reference angle theta, but in consideration to the definition of our cosine function. So secant with respect to theta is equal now to the reciprocal of the definition of our cosine, which is hypotenuse over the adjacent side. And lastly, for the cotangent function, it is the inverse or the reciprocal of our tangent function. So for us to be able to define this cotangent with respect to your angle theta, it can be defined as adjacent side over the opposite side of our right triangle. Okay, so these are the 6 important terminologies that we often apply when we are learning trigonometry. Okay, let's repeat the definition. For secant for sine with respect to angle theta, we have opposite side over hypotenuse. For cosine with respect to angle theta, we can define it as cosine theta is equal to adjacent side over the hypotenuse of the right triangle. For tangent function, or for the tangent, we can define it as, or with respect to our angle theta, it can be defined as opposite side of the right triangle over the adjacent side of the right triangle. For the fourth one, we have the secant with respect to your reference angle theta. It is hypotenuse over the adjacent side. For the cosine, or cosecant, sorry, with respect to our angle theta, it can be defined as hypotenuse over opposite of the right triangle. And lastly, for the cotangent, we can define it with respect to our angle theta, or reference angle theta, as adjacent over opposite side of our given right triangle. So take note, before we can define these 6 important concepts, we, as I said, need to consider our right triangle with respect to a reference angle. Okay, so for you to be able to locate the reference angle, just set any of these 2 acute angles to be your reference angle. Okay, and of course, after defining this, okay, after defining these 6 important concepts in trigonometry, this will now become functions. Okay, this will now become formulae. And these formulae are often applied when we are computing, or when we are solving unknown parts of a right triangle. Can you follow? So I think this will now be the end of my video lecture presentation about the 6 important concepts that we need to know when we are studying trigonometry. So thank you again for watching to this video. Have a good day, everyone.